Welcome to solverfy.
Okay, we have the following molecules. We have a 2, 3, 4, 5, 6, 7 carbon chain with 2 methyls, a bromine, and a methyl. We have another molecule that is a 2, 3, 4, 5, 6 carbon chain with a methyl, and a hydroxyl. A 6-membered ring with a hydroxyl. A 3-carbon chain with a methyl and a bromine on carbon 2 and a bromine on carbon 1. And finally, a 6-membered ring with a double bond between carbon 1 and 2, a methyl on carbon 1, a methyl on carbon 2, and a methyl on carbon 4. And the question is, which of these molecules are chiral? Well, recall that for a chiral molecule, we require that a given carbon be attached to 4 unique substituents, right? So any of the examples where we have a terminal methyl, that's not chiral because there's 3 hydrogens. Any of the examples where we have a CH2 in the middle of a chain, right? Hydrogen, hydrogen. There's 2 of the same substituent. Those can't be chiral, right? And then the remaining molecules that can, or the remaining carbons that can be chiral then are those where we see 3 substituents that appear to be unique. For example, a hydrogen, a methyl, an ethyl, and then the rest of this chain are all unique substituents on that carbon, right? So it is possible for this molecule, or at least for this carbon, to be a stereocenter. Likewise, it is possible for this carbon to be a stereocenter, right, because of its 4 unique substituents. What about this carbon, right? Well, notice that it has this chain and this chain, which are identical, so that cannot be a stereocenter. The point is this molecule has 2 carbons that can potentially be stereocenters. So this may be chiral. The one thing I'll point out is that if these are, for example, both depicted as wedges, this compound would contain an internal mirror plane of symmetry, and so it would be meso. So it's potential that this is chiral, but not guaranteed. But I would say yes, just based on the simplicity of this question, this molecule is chiral. Okay. Next, we have a sort of similar case, right? Let me make this a little more clear. I drew it a little sloppy. There we are. So let's look at each of the carbons that could potentially be chiral. This one has 2 methyls, so it's not chiral. Likewise, this carbon has 2 methyl groups, so it's not chiral. However, this carbon here has an OH, it has a hydrogen, has an isopropyl, and then it has this sec-butyl, I believe, right? So that is a stereocenter, and so this molecule is chiral. 2 is chiral. I'll put a check mark. 1 can be chiral. Okay, our cyclohexanol, this is not chiral, right? And the reason for that is that all of these carbons are CH2s, except for the one that contains our hydroxyl, but that even though we contain a hydrogen and a hydroxyl and then some sort of chain and some sort of chain, as it turns out, each direction along the cyclohexane molecule is identical. And so those are not considered unique substituents, right? We'd go CH2, 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 CH2. All of a sudden we've met in the middle. And so each side of that chain is the same. Therefore, the carbon doesn't have 4 unique substituents. So 3 cannot be chiral. I'll put an X next to it. Okay, can this molecule be chiral? Well, note that this bromine, or this carbon with the bromine, has 2 hydrogens. That's 2 of the same substituent, so this cannot be a stereocenter. And this carbon has 2 methyls on it, right? So this cannot be a stereocenter. And then the remaining carbons are methyl groups, and we know methyl groups cannot be stereocenters. So 4 is not chiral. And finally, we have number 5. And this molecule can be chiral. Now, there's no stereocenters among these carbons here. But if we look at this carbon, we'll notice that, one, it's attached to a methyl group, as well as a hydrogen. So methyl group, hydrogen. And then it's attached to this side of the ring, that's a CH2, and this side of the ring, that's a CH2. Then we go one carbon further and we get a carbon and a double bond. When we go one carbon further on the other side, it's still a CH2. So in fact, both sides of these chain are not the same. So 5 can also be a chiral molecule.